Hello everyone. In this second lecture, in continuation of the lecture we had about domain of functions, we want to focus on range of a function. We said that the range set is the set of all possible resulting values of the dependent variable y after substituting all possible x values. In other words, the set of single output numbers for a function. So for domain, we had standard procedures to follow. For example, if you had a denominator somewhere in a rational function, you knew that the denominator cannot equal to 0. So that was a solid procedure to follow. Or if you had a square root, for example, you would know that the radicand, which is the expression under the radical sign, must always be positive or 0, but it cannot be negative. So these are like solid rules that you can always follow. Or for example, logarithm of negative numbers and 0 is undefined. That's another solid rule that you can follow. But in case of finding range, we don't have such solid rules. And most of the time, by knowing the shape of the graph of the function, we can find out about the range, or there's also other techniques, but no solid standard procedure like the domain that we can quickly follow and find the range immediately. 4x cubed, y equals 4x cubed is just the basic cubic function, y equals x cubed, which of course it has undergone a transformation vertically stretched by a factor of 4, which is not going to affect the range of the function. So you have to know the domain and range of basic functions in and out. Otherwise, you should not continue watching this lecture. So here we're going to say the range of the function R sub f. The range of the function is actually the set of real numbers, or you can say that open interval from negative infinity to positive infinity, just like the range of the original function. You know how the shape looks like. The shape of the function would be something like this, and as you see, it is stretching from negative infinity to positive infinity, and there's a whole bunch of negative y values that are possible, a whole bunch of positive y values that are possible for different values of x, and also 0 is also okay. So the range of this function is the set of real numbers. Absolute value function, well, we see that we have a vertical stretch by a factor of 6, along with a reflection in the x-axis, horizontal shift 5 units to the right, and vertical shift up 11 units. So the graph is going to have a maximum value at 11, and because it's reflected in the x-axis, the graph will be below 11. All the points on the graph would be below y equals 11. So we're going to say the range of this function is the set of real numbers such that y is less than or equal to 11. Okay? And as I said, you need to know how the graph of this looks like. I can't sit down and do all the graphs of these functions, but you have to know it. You can use, for example, graphing software such as Desmos or graphing calculator, and quickly perhaps graph these and see how the graph looks like, and then you can quickly find out what the range is. Or you can just use the transformations and the properties of the functions, and using the graphs of the basic parent functions, you can figure out how the graph looks like, how is it transformed, and as a result, you can find out what the range of the function is, and that's what I'm doing here. This is an exponential function undergone 2 transformations, horizontal shift to the left by 2 units, and vertical shift down 3 units. So I know how the graph of horizontal exponential function looks like, and if you shift it to the left or right, it doesn't matter to the range of the function, it doesn't affect the range of the function. But the thing is that when you vertically shift the exponential function down by 3 units, the horizontal asymptote, which is attached to the graph, also shifts 3 units down. As a result, it affects the range. So for this one, we're going to say the range of the function is y values greater than belonging to set of real numbers such that y is greater than -3, but not equal to -3. Even for exponential function y equals 10 to the exponent of x, which is sort of basic exponential function, we never said y is greater than or equal to 0. because we knew that the graph does not intersect its x-axis. So we would say y is greater than 0 all the time. So here, because we have a vertical shift down 3 units, we would say y is greater than -3 instead of saying y is greater than 0. This one is a square root function. We know how it looks like. There is a horizontal shift to the left by 7 units and a vertical shift down 8 units. So we're going to say the domain is numbers, sorry, not domain. The range is numbers like y belonging to the set of real numbers such that y has to be greater than or equal to -8, which is the amount of vertical shift down for this square root function. So this is r sub f, or the range of the function. Again, you have to know how the graph looks like. If you do know how the graph looks like, if this is the x-axis and y-axis, so a graph is horizontally shifted to the left by 7 units, something like that, and then 8 units down, so it looks like something like this. So here, the lowest point is actually -8, which happens at x equals -7. So the whole graph is above -8, clearly. So that's why we say y is greater than or equal to -8. As I said, you have to sit down and graph all of these so that you can visualize the range of the function. So for this one, we have a reflection in the x-axis, and then vertical shift up 8 units, so everything would be below 8. So y is less than or equal to 8, basically. Any real number less than or equal to 8 would be the range would be within the range of this function. This one is a rational function, and the horizontal asymptote is the x-axis. So horizontal asymptote for this function is y equals 0, which is the equation of the x-axis, and this graph does not intersect its horizontal asymptote. It doesn't intersect the x-axis. We don't even have an x-intercept. If you set y equal to 0, you would have no solution for the resulting equation, which means that there is no x-intercept. And that means that y can never ever be equal to 0. But other than that, it can be positive numbers, it can be negative numbers, no issues. You plug in like -10, you end up with a negative answer for y. You plug in +10, you end up with a positive value. So for different values of x, you will have different values for y. Some are positive, some are negative. We have no issues. But with the 0, we have the issues because this rational function does not intersect its x-axis, and y can never ever be equal to 0. So I'm going to say the range of this function is all real numbers except y cannot equal to 0. Other than that, it can be equal to any positive or negative number. This one is a logarithmic function, and we know that the range of a logarithmic function is the set of real numbers. So if you horizontally shift the graph by 1 unit to the right, it's going to definitely affect its domain. It is going to affect the equation of the vertical asymptote. Instead of being x equals 0, it's going to be x equals 1. But that vertical stretch by a factor of 2 also does not affect the range. Therefore, for this function, the range is still the set of real numbers, and it doesn't change. It's the same as the range of the basic logarithmic function. Another rational function, this time the horizontal asymptote has an equation in the form of y equals 1. And if you draw the graph, you will see that the graph does not intersect its horizontal asymptote. I'm not saying it's impossible, for all functions, never ever intersecting their horizontal asymptote. It is possible. There are some rational functions where the graph is in a way that it intersects at some point, intersects their horizontal asymptotes, but not in this case, at least. So we're going to say that y cannot equal to 1 because y equals 1 is the equation of the horizontal asymptote. Even if you set y equal to 1 and you cross multiply, you will not be able to solve the equation because the resulting equation will have no solution. So here we're going to say the range of this function r sub f is all real numbers except that y cannot equal to 1. That's what we can say. It cannot equal to 1. Other than that, it can equal to any other number. Sometimes it could be positive, sometimes it could be a negative y value. This one is a cosine function or a sinusoidal function. And we know that sinusoidal functions, either sine function or cosine function, they always fluctuate between -1 and +1. Now here we have an amplitude of 2. So that means that the graph has undergone a vertical stretch by a factor of 2, which would affect the max mean values. So the maximum value of the cosine function, or I should say 2 cosine function here, would be anywhere between -2 and 2. And then the thing is that the negative sign, of course, causes a reflection in the x-axis, which is not affecting the range. If we had only -2 cosine of the angle x minus 30 degrees, which again, it doesn't affect the range or even the domain, because a horizontal shifted right by 30 units, 30 degrees, it doesn't affect the range. But that plus 10 affects the range big time. Because when you say plus 10, it means that you are vertically shifting the cosine graph 10 units up right away. So it definitely affects the range of the function. I would say the maximum value for this function is, I would say 12, and the minimum value is, of course, 8. Because if you think about it, the amplitude is 2, and we have a vertical shift of 10 units. So from 10, which represents the location of the axis of the curve, y equals 10 is the equation of the axis of the curve. 2 units higher would be 12, 2 units lower would be 8, obviously. So the whole graph is actually fluctuating between 8 and 12. So we're going to say any real number that is between 8 and 12 inclusive, I'm not saying exclusive, inclusive, then in that case, that would be the range of this cosine function, which has undergone some transformations. If you draw a quick sketch of this, well, I would say if this is the x-axis, and if this is the maximum line, y equals 12, and this is the minimum line, y equals 8, then this middle line is the axis of the curve, y equals 10, and we have a shift to the right by 30 degrees. So let's say if 30 degrees is this much, okay, so we are starting from the minimum line because of the reflection in the x-axis that is involved. So the graph should look like something like this. Of course, I'm not drawing it to scale, needless to say, but it's a graph like this. And on the left, it's going to look like that. And it keeps fluctuating between the two values, 8 and 12. And that is the reason why we say the range is any real y value between 8 and 12 inclusive. Okay, so I think I gave you 9 examples. I found a range of 9 functions. And already I had explained the domain of 9 other functions in the previous lecture. So right now, we sort of know how to find domain and range of different functions. We may talk about this later again. Thank you very much.